All right, 2.4. We're going to split 2.4 into two sections, A and B. All of 2.4 is about solving quadratic equations algebraically. There's four methods: factoring, extracting square roots, completing the square, and quadratic formula. So 1 and 2 are going to be videos A, 2.4A, and 3 and 4 is going to be part B. So you have one notes page, but it'll take 2 videos for me to explain it, just so it's not too much information at one sitting. All right, so you've seen all of these. Should be review from like Algebra 2, but here we go. The first method is factoring. Factoring can just look like greatest common factor, or it can be like FOIL, box, whatever you like. So the goal here at factoring is I want to get it equal to 0, first of all. So I'm going to start by subtracting 3x from both sides. Once it's equal to 0, then I want to look at how do I factor this. There's only two terms. So I can look, first of all, is there a greatest common factor? Okay, what can I factor out of both of these terms? Well, I can divide both of them by 3, and I can divide both of them by an x. So that would give 3x. And if I take 3x out of the first term, that leaves me with 2x. And the second term, if I divide that out, that leaves me with a negative 1. All right, so you don't want to stop here. You want to solve this all the way for x. So the way that you would do this is separate the 2 out. So I have 3x equals 0 and 2x minus 1 equals 0. Both parts set them equal to 0 and then finish it. Divide by 3, x is equal to 0. Here I need to add 1 to both sides. So I have 2x equals 1, divide by 2, so x equals 1/2. So it's quadratic, meaning it has two solutions. So here's my two solutions, 0 and 1/2. All right, that's a GCF one. Look at number 2. In order to factor, to solve this, I need to get it equal to 0. So I'm going to move that negative 1 over by adding 1 to both sides. So I have 9x squared minus 6x plus 1 equals 0. Now it's a trinomial, 3 parts. So I'm going to try to figure out how to factor this. So I'm going to take a times c and see what adds to b. Remember your general form of the equation? It looks like this. So a times c are those outside coefficients. So in this case, it's 9 times 1. So it gives me 9. Okay. And b is a negative 6. So I'm looking for two numbers that multiply to positive 9, yet add to negative 6. If you can do your factors of 9, you should get negative 3 and negative 3. Okay. Two negatives make a positive. Do they add to negative 6? Yes. So the way I would recommend this, there's more than one way to do this, but if you use box method, you put in the very first term in the left top square, and then the last term in the bottom square. The middle two terms come from your table here. So I'm going to put in a negative 3, and you put an x on them. Now, to find your factors, you're going to do greatest common factor up and to this and horizontally to the side. So between 9x squared and negative 3x, what is the greatest common factor? Well, I can take a 3 out and an x. Don't worry about the negative, that comes in later. Now, if I look at this column, negative 3x and a 1, really the only thing they have in common is a 1. One of them's negative, one of them's positive. So if this one's negative, then that negative gets pulled out right here. So here's one of our factors. Now, horizontally, do the same thing. 9x squared minus 3x. What can I take out? A 3 and an x. Negative 3x and a 1. I can only take out a 1, and it's negative as well. So here's my other factor. So I have 3x minus 1 times 3x minus 1 equals 0. Not finished, because I have to set them equal to 0. If they're both the same, you're going to come up with this same answer. But if I add 1, I have 3x equals 1, divided by 3. So x equals 1/3. And since both factors are 3x minus 1s, this would be a double root. Not a big deal if you know that, but that's why you have two answers. because you would have had that same answer twice. All right, number 3. All right, looks like a trinomial, but it's not equal to 0. So we need to move this 6 over. And when I do, I get 2x squared minus 3x minus 5 equals 0. So I need to do that whole box thing again. All right, so think of your table. A times c, so the 2 times, look at your 2 times negative 5 is negative 10. And it has to add to b, which is negative 3. Two numbers that multiply to negative 10 yet add to be negative 3 would be a positive 5 and a negative 5 and a positive 2. Those would add up to negative 3. So those work. All right, so then I build my little table. X squared goes in the top left, and then the minus 5 goes in the bottom right. Here's my 2 factors, so I can put negative 5x and 2x. And then I do greatest common factor by row and by column. So here's my first column, so this is 2x. And this would be 5, negative 5. In the first row, what do they have in common? Well, they really only have an x in common. 2x and negative 5, they only have a 1 in common. That 2 right there is positive, so that makes that positive. So my 2 factors are 2x minus 5 times x plus 1, still equal to 0. So then I set each factor equal to 0 and solve it for x. So this is 2x equals 5, divide by 2, x equals 5 halves. So negative 1, so x will equal negative 1 here. So there's my 2 solutions for those 3. All right, number 4. Notice it's a trinomial. It's already equal to 0, so I don't have to move anything over. I can jump right into the factor stuff. So a times c would be 3 times negative 2 gives me negative 6. B goes in the middle. So I'm thinking of 2 numbers that multiply to negative 6, but add to a positive 5. So I'm thinking it would be a 6 and a negative 1. If I multiply those, I get negative 6, but if I add them, I get a positive 5, so that works. All right, then I put it in my table. I have 2x squared and negative 3. My 2 factors are a 6x and a negative 1. Greatest common factor by column here would just be a, oh, that has an x on it, sorry. This would be an x. These 2 would be a 3. And that 6 is positive, so this is going to be positive 3. First row, I can take a 2 and an x out. Second one, I can take out a negative 1. So my 2 factors then are 2x minus 1 and x plus 3. Still equal to 0. So I set each individual factor equal to 0 and solve it for x. So 2x equals 1, divided by 2, x equals 1 half. So x equals negative 3. I'm done on that one. So there's my 2 solutions on that one. Easy enough. All right, let's try number 5. If you want to pause the video and try it yourself and then see if you get what I get, go for it. Whatever you need to do to build your confidence in factoring, but you have to be able to factor. All right, it's already in trinomial form, already equal to 0, so I'm going to build my little table. A times c gives me negative 6, but the b value this time is negative 1. So what 2 numbers multiply to give me negative 6 yet add to give me a negative 1? Think through your factors of 6, and I would get negative 3 and a positive 2. They add up to negative 1, so I can build my box. 3x squared minus 2 goes here, so I have a 2x and a negative 3x. First column, they have in common a 3 and an x. Second one, they would have a 2 in common. This 2x right here is positive, so I'm going to make it positive. First row, they have an x in common. Down here, they have a negative 1 in common. So I have 3x plus 2 times x minus 1 equals 0. And if I set each factor equal to 0, solve them. So I have 3x equals negative 2, divide by 3. So x equals negative 2/3. There's one solution. X minus 1 equals 0. Well, that's just x equals 1. There's my second solution. All right. Number 6. Okay, we got some bigger numbers here. Don't let it scare you. I would first think about your factors. Okay, a times c, 4 times 8 is 32. So you have to multiply to 32, yet add to negative 33. Well, probably 32 and 1 would be my guess here. And they both have to be negative to add up to negative 33. All right, so let's do our box. So I have 8x squared and positive 4. Then I do a negative 32x and a negative 1x. Okay, by first column here, where they have in common, they have an 8 or an x in common. Second column, they would have a negative 4 in common. First row, what's the greatest common factor between these two? An 8 and an x. Bottom row, it would be a negative 1. It's negative because this is a negative, right? So then my two factors come out as 8x minus 1 and x minus 4. All right, set each factor equal to 0. Solve it. So I have 8x equals 1. Divide both sides by 8, and x equals 1 over 8. And add 4 to both sides for the second one, so x equals a positive 4. All right, so there's my two solutions. This is doing factoring. Now the second method for solving quadratics is by extracting square roots. All right, so let's scroll on down. All right, to extract square roots, first thing we need to do is isolate the squared x value right here. So I want to get rid of that 4. So I'm going to divide both sides by 4. So I have x squared equals 3. Now, so to get rid of the x squared, I take the square root of both sides. Now, when you take a square root, be careful here, don't get too far ahead of me. You're really taking the absolute value of that square root of 3. And then when we solve for absolute values, remember, you have to solve for the positive and the negative. So what that means is that you have two solutions, is that x is equal to negative square root of 3 and x is equal to the positive square root of 3. All right, there's two parts there. What you're having when you take a square root is you're taking the absolute value, but remember when you solve square roots, you have two solutions. All right? Okay, so to take the square root of this, I'm going to take the absolute value of what's inside instead of equal to the square root of 7. Now, anytime you solve an absolute value, you have to consider there are positive and negative possibilities, right? Because absolute value makes it all positive. So then I have to solve it two ways. I have to say x minus 3 equals positive square root of 7, and x minus 3 equals negative square root of 7. Right? Either way, you're going to be adding a 3 to both sides. Right? So you can combine your answers to look like this. You could put the plus or minus in there. Okay? That's what your solution should look like. Or if you're not happy with that, you could call it x equals 3 plus the square root of 7 and x equals 3 minus the square root of 7. Either one's okay with me. I'm okay, as long as you understand that we have to deal with the positive and the negative possibilities there. All right, let's try another one here. On 9, we want to take the square root of both sides. So it's the absolute value of 2x minus 1 equals, now, remember that is negative 1 times 9, right? Well, it's a perfect square. That's 3i. We take the square root. Now, we have to consider that that is positive or negative 3i, right? To drop the absolute value, you have to consider both possibilities there. So if I'm going to finish this, I'm going to add 1 to both sides. I have 2x equals 1 plus or minus 3i. Not finished because x is not isolated, so then I need to divide all of it by 2. So x is 1 plus 3i, or plus or minus 3i divided by 2. Okay, if you want to separate that out, you can, but you can just leave it like that. That is perfectly acceptable. All right, so we're going to stop there. I want you to practice with these concepts, factoring and extracting square roots, and then we will do the rest of 2.4 in the B video.